Friends, this is Durga again from ITversity. As part of this topic, we will see companion objects and case classes. This is another very important topic, especially to build skills related to Spark. Already we have seen object, which is nothing but a singleton class, and also class. First we will see what is a companion object, and then we will get into case classes. So if the class name and the object name are same, then the object is termed as companion object to class and vice versa. Class is also termed as companion class to object. A companion object differs from other objects as it has access rights to the class or trait that other objects do not. So you can even access the private variables. For example, I'm launching Scala here, and then I'm going to paste mode. I'm creating a class, okay, and I'm just giving name A, and I am actually saying private val message string. That is the definition of the class. Okay. Now I can actually invoke this A with value from an object. So here to create companion object, I can say object A, and then I can define the functionality wherein we can say val A equal to new A, hello world, and also I can say println a dot message, which is a private variable for class A. And now I can do control D, and now I can actually invoke the object by saying A, and you can see the hello world here. If I change the name of this, instead of A, let me give it as B. Okay, rest of the stuff is same. Object B, and it will fail, saying that class A cannot be accessed in A, which is object. Okay, I don't know, always a little bit misleading. Actually, this is not a companion object for this class, hence it cannot access this private message. Only the companion objects can access the private messages. That's the major difference between regular object and a companion object. And companion object will carry the same name as the class name, but the parameters cannot be passed for an object. Arguments or parameters cannot be passed for an object. Okay. I will also explain the typical implementation. We will create the class with whatever name we want, and then we'll create the object with the same name. And typically we use apply method in the object, which will take all the arguments as the class, and then we will instantiate object of the class in the apply method, and then we will use object supply method to create the objects for the class. So it sounds a little bit tedious, but when you see the usage later, you will understand, or you will admire it. Anyway, before getting into those details, or we will get into those details later. For now, let us see the details about the metadata of the created class after compiling this companion class and object. Okay, so here I am taking the old code which worked earlier, getting onto the paste mode and paste it, control D, and now you see there is a class A and object A. To get the metadata of class A, you just have to say java p-p capital A, and it will give the metadata of class A. For the object, you have to use capital A dollar and hit enter, and then it will give the metadata of the class created for the singleton object. Okay, Because it is a companion class, it will have some additional methods. For example, if I just create the object like this, okay, let me create a class B, and then val message string, and then let me create object B, wherein I will be creating this one, and then print ln a dot message. Okay, so in this case, they are separate classes, not companion. Even though names carry same, we executed as different blocks of code rather than executing it as one unit. Hence, it is not actually companion class. B is not a companion class, companion object for class B. Okay, so here you can see the code generated. It is almost same. I thought it will be different, little bit different. Probably the implementation could be little bit different. Okay. Anyway, this is the reason why we need to use dollar at the end while invoking Java P command on the object. Objects will have dollar at the end as part of the compiled code, compiled bytecode or dot class file after the compilation. Okay, so now we will get on to the case classes. Case classes is a special type of class, and let me create a case class. First, let me create a normal class for order item. Okay, I don't want to create all the parameters here. I will just take this portion from this code. You can also take it from the previous blog overview of classes, and you can take the code for order item, and in this case I am just interested from here to here. Okay, and if I paste it here, okay, there is some special character I guess in the end. Okay, and this should have been here. So to address this issue, I have to just do paste, and now it will be compiled as one unit. Okay, the class is defined, and here you can say Java P hyphen P order item, and you can see there is only a constructor for regular class. If I want to create a case class, I just have to say paste and then case and paste the rest of the stuff. It will become a case class, and then Control D, and then now case class is created. Now case class have a companion object also associated with it. Okay, so here we have to run two commands, Java P hyphen P order item, and also Java P hyphen P order item dollar. Okay, this is the companion object. And now if you go through the details, you can see this order item implements serializable. So the case class is a special type of class which implement serializable, which means we can actually use it for scenarios where the object has to be serialized, and also it implement product. Due to the implementation of product, it gets few additional functions such as product arity, product element, product iterator, etc., which I will cover in a moment. On top of that, there will be a default two-string function implementation. There will be a constructor. By default, the variables in case class is of type val. So automatically, you will get getters. Whereas in case of regular class, the default are just constructor arguments. They are not variables. Unless you say val or var, they will not be treated as variables. Whereas with respect to case class, each of these variable is val, which means immutable class variable. Okay, so because we left it to default, all we can see the member variables, and also we can see the getter methods for all those things, and on top of that there is a set of copy commands and so on and so forth. We have can equal, we have overridden functionality for hash code, etc. Okay, on top of it we also have a companion object for order item, which is represented as order item dollar here, and it have apply and unapply function. Okay, so here first we need to understand the purpose of the apply function. So the apply function will work like this. Let me create class A. Let me go to the paste mode. Here I am creating class A, okay, which takes a variable integer. Let me use it as val so that I can access the variable, and then I want to create object with name A. Here I am defining an apply function, okay, and here also I am passing a argument, one argument which is I and type integer, and then in this I am actually returning the object of type A with the argument which is passed, which is I in this case. So I am instantiating an object of for class A, and then I am returning as part of this apply method. Okay, then I am closing for this apply method, and then I am closing for object, hitting Control D. Now we have the class A and companion object A. Now you can invoke this apply method like this. So if you want, you can say val A equal to A dot apply of 10, because it takes one argument, and it works fine. And then you can actually access. Okay, I know the problem. So here okay, so here A is of type object here, and it has apply function, and apply of 10 it has created the object, and I can say A dot I, and I can actually access the variable which is declared as part of the class, because as part of the apply method we are creating the object of class A. Okay, so apply is a special method where you don't need to call, you don't need to specify to invoke it. If you just say object name, if there is a apply functionality associated with it, then it will automatically call the apply. So in this case, now the A is created again, and A dot I returns 10. If I create A with 20, A dot I will return 20. Okay, so the apply method is a special method where you don't need to type apply to invoke it. You just invoke with object name and pass all the arguments, and it will be taken care. For class, it's a little bit different. If there is apply method for class, instead of so now let me paste here, and okay, let me do this. Let me copy this one, and I'm creating apply method here equal to print ln inside class apply. Okay, now the class functionality is done. Now I am creating the object. Control D, and if I say like this. This is object, and apply method will be invoked when I say object and then pass the argument without dot apply. Okay, and I can access I with a dot I, which is the class member variable. Now if I want to invoke apply method of the class, once the object is created, I can just say it should have invoked the apply method and I should have seen this output. Let me see, a dot apply, inside class apply. Okay, so I could not get it right. I think it has to return something, because it is not returning something, it is failing. So let me paste it here again. I'm not sure whether it will work, but let me give a try. Yeah, I think now it should work. Now I'm creating the variable, and then I'm saying EA. It is still not invoking the class supply method. Anyway, class supply method is not very important. As long as you understand that the object supply method, that is good for now. If it is required, I will cover the class supply method in a separate video. So now if we go back to Java P order item, which will return the metadata of the class, and order item dollar, which will return the metadata of the companion object of the case class. Okay, so order item is nothing but a case class, and you can see there is a default functionality for the apply method and also something called unapply method and few more. Okay, so all these things are automatically provided to you with just one line called case class. Now if I want to create an object of it, okay, so I'm using OI as the variable name, and it is always better to invoke using apply method of the companion object, because that apply method have the functionality to create the class object. Okay, so here I am using companion object supply method by saying order item, and it takes 6 parameters. Okay, one is order item ID, other one is order item order ID, etc. 1 comma 1 comma 1 comma, then quantity, then 150 is the subtotal, and then 50 is the revenue. So 50 is the price of each item, and hit enter. Okay, here I have to say F and F. Okay, now you see automatically instead of returning the byte address, it actually returned the details of the object created. That is due to the toString function being overridden as part of the class that is compiled when we create case class. Okay, so this is the default behavior. And if you observe, even as part of the last topic when I explained classes, I have similar toString function for almost all the classes. Okay, you can go here and see I have overridden the toString function. Such thing is already available for you as part of the boilerplate code which is generated when you actually create the case class. On top of it, there are some other important methods. So once you create the object, you can definitely access by saying OI dot order item ID or OI dot order item subtotal. That's because each of these are class level variables um, which can be accessed because of these getter methods. Okay. On top of it, you can see there are some product prefixed functions like product prefix, product arity, product element, product iterator, etc. These are all uh, due to means if you see the specification of the class, which is the output of after comparing the case class, it is also implementing Scala.product, and these four functions are from that interface, for which the case class will have the implementation for you out of the box. So, uh, um in case of product parity, it doesn't take any parameter, but it will give the some integer. What is that integer? So in this case, if I say oi dot order item subtotal, and then sorry, I don't think that is the case. Let me see. Product arity doesn't take any parameter, so y dot okay product arity. Okay, product arity is the number of elements in the case class, or number of arguments in the case class. It so here it is 6, and product element will actually fetch the element. So you can say product element, and if you say 0, it will fetch the first element. If you say 5, because we have 6, it will fetch the last element. Product iterator, you can actually iterate through those elements and get the results. So it will generate the iterator, and you can actually iterate through them. So you can say y dot product iterator dot for each println. Don't worry too much about this for each. I will try to cover later. So this is how you can actually iterate using for each and print all the elements or all the attributes which are passed to create the object of the case class. And then product prefix. Let me see uh, what argument it takes. It doesn't take any argument. Okay, so let me see y dot product prefix. Okay, you have to pass the argument. Okay, so one is giving r, I don't know why it is giving something like this. I don't know what this product prefix is for, but I have covered the rest of the stuff. We can explore as and when it is required. Okay, so that is about case class. Case class is nothing but a special type of class which is serializable, which implements product, which provide boilerplate code for such as getter methods, the product functions, the toString function, etc., and also which will provide you a companion object with the default apply behavior, where it will create an object of the underlying class. So that is about companion objects as well as case classes, which is very important when it comes to Spark, especially with respect to data frames, and we will try to revisit these things at that time. That being said, thank you, bye.